can see that the note guide has vocabulary at the top. This vocabulary is also in your textbook. So as far as getting the definitions, these are the exact definitions out of there. You can always go back to your textbook and refer to that. It might actually be more helpful if you write what it means to you as we go through the lesson. But that's up to you, because remember, your notes are for you. So first word we see up there is sequence, which is an ordered list of numbers. So all it means is you're looking at a list of numbers, but the first term is the first one. You can't like rearrange them. They're going to stay in that order. Okay? So you guys look at sequences before, but you just might not have thought of them as a sequence. You might have just thought of it as like a list of data or a list of numbers or something like that. Okay? The term of a sequence is each number in the sequence. So there is a first term, a second term, a third term, a fourth term, and sometimes they will use the language nth term. What do you think they mean when they say nth term? Yes. Good. Okay, you don't know which term this shows up as, but you know it's in the list. You just don't know in which spot. So that's when they're using n. It's like when you're solving an equation using algebra and they say like, you know, those silly word problems like so-and-so's age and then his father's age, you usually plug in like x for what you don't know. Same idea here. When we don't know what term it is, we just tend to call it the nth term. That's just the variable we chose to use. Explicit formula and recursive formula, we'll talk about the definitions right now, but those will become much more clear as we actually talk about the mathematics. Those are things that it's going to be more familiar to us if we see it in context than just read the crazy definition that like the glossary gives, right? So an explicit formula describes the nth term of a sequence using n, okay? So what that means is we talked about nth term means there's a term, you don't know where it is, but you know, like say 40 shows up in the list. N is where it is. Again, if you like the definition, write it down. If you don't. We're going to get back to it, and you'll see it in context. Okay? But explicit is like plug in an X and get a Y kind of idea. Okay? Kind of like how the equations you ended up writing on your poster at the bottom, those would be considered explicit formulas. Recursive formula relates each term after the first term to the one before it. So it basically says this. Let's see. So you guys were working with the cups yesterday. We said a cup was 14 centimeters high. Right? So a recursive formula would say, in order to get the height of the stack when you put the second cup on, take the first cup and add to it however much. How much would you guys decide to add? You guys measured and stuff yesterday. 2, 2.5. Some people say, let's just use 2 for simplicity of the number in this demonstration. I'm not saying anybody's right or anyone's wrong. Okay, but if it was 2, then we'd say you take the one before it and you add 2. If I want to get the height of the stack with 3 cups, I would have taken its height at 2 cups and I would add 2, right? If I want to get the height of the stack with 4 cups, I would take its height at 3 cups and I would add 2. That is a recursive rule where you say take the height it was right before that and just add or subtract or do something to it to get the next one in the order. Okay? So recursive is usually the patterns we see more simply, but not as useful, because if you wanted to find out how tall the stack is when there's 100 cups and you're using the recursive rule, you would have to know how tall it was with 99 cups before you could figure out the 100th cup, which isn't very useful because then you still have to go through a lot of work, right? To find out how tall it was with 99 cups, you'd have to know how tall it was with 98 cups and do the little thing you have to do to get 99 cups. So it's more intuitive, like you can look at patterns and see them, but it's harder to figure out terms down the road using the recursive rule because you have to know the one before it, okay? So notation is going to be important for us. So we're used to seeing a list of numbers, let's say, okay. So let's say our list consists of 1, 3, 5, 7, 9. So this is a sequence, okay? If, for notation, this is how a mathematician and how your textbook and how the things you're going to see would note the sequence. What term is 1? 1 is the first term. 7 is the fourth term, okay? Maybe down here somewhere, 21, if I don't know what it is, I would say nth term for right now till I figured it out, and then I could figure it out. Okay? First term would be denoted like this. So we use the letter A, not really as a variable, but more to represent like this is a number that's in your sequence. Okay? It's a term in your sequence. Which term is it? This little subscript number right here tells us. So when they say A1, they mean the term that is the first term. So first term. Okay? So 3 would be the second term, 5 would be the third term, etc. Okay? So when they talk about the nth term, they write it like this. So A is the letter you're going to consistently see, meaning it's one of the numbers in your list. It is a term. Okay? The little subscript next to A is going to tell you at which position it is in your sequence. Is it first? Is it third? Is it eighth? Is it 100,000th? Okay? I don't know. So nth term is just going to have a little n here because we don't know which one it is. Any idea how a mathematician would note the term that's right before the nth term? Good. If you want it to be right before the nth term and you don't know which one the nth one is, you would just write n minus 1 because it's one right before the nth one is, even though you don't know where it is. So what would be the one right after the nth term? N plus 1. What would be the term that's 5 spaces after the nth term? N plus 5. So we get how the notation works. Don't be scared of it. It's just notation, okay? It's all the things you already know, but written in a format that mathematicians like to use, okay? All right, so talking about the cups real quick, a side note. A recursive formula for the cups would say you find the height of the stack of cups by taking the height it was 1 cup before, and we said we're going to count the rim as 2, and adding 2 centimeters. So just to give you some context of what recursive and explicit means, this is a recursive formula because to figure out this one, I need to know the one before it and just do something to that. So that makes this a recursive rule, okay? Does that help differentiate what they are? We'll talk about an explicit rule in a little bit. Okay? All right. All right, so a sequence has an explicit formula. So they're telling you there's a sequence. They're giving you the explicit formula for the sequence. There it is. So this is an explicit formula. If you were having a hard time understanding that definition, highlight explicit and notice how it looks. You're still looking for the nth term, so whatever term you want that to be. But look at what's on the right side of the equation. Do they use any other term in the list to figure it out? Is there any A's on the right side of the equation? No. So they don't use anything else in the list to figure it out. So if I want to find the 20th term for this, I plug in 20 for n. But I don't have to know any of the other terms that are in the list. Does that make sense? Okay. So here they're asking us for A9. What are they asking for when they ask for A9? The 9th term in the sequence. Because I have that rule for the sequence, I just do the calculation. So this is the name, the 9th term. Notice that 9 is replacing n in the formula. Okay? Because it's not the nth term anymore, they told me. I'm looking for the 9th term, so I don't have to call it n anymore. That means in the formula, n becomes 9. And when I finish this calculation, I'm going to know which number is in that ninth spot in my list, or my 9th term in my sequence. Okay? So 9 times 12, is 108 plus 3, 111. Will somebody please check my arithmetic? It's good? Okay, perfect. Thank you. So the 9th term of the sequence is 111. Fair enough? So do you see why people would like to be given an explicit formula? Now, if I wanted to find the 100th term, I can just plug in 100 and find the 100th term. I don't have to know the 99th and the 98th and the 97th to figure out the 100th term. Okay? Are we good with the notation and how all of that works? All right. Now we're going to look at this in order to write a recursive pattern, but then we're not going to do a lot of the other portion of your note guide in this section, just because I want to focus on one specific type of sequence, okay? So to write a recursive rule for this sequence, now this is given to you visually, but notice it says next to the example that it's the number of blocks that we're looking for. So in the first term, how many blocks are used to make that visual? 1 block. And then in the second term, there would be 3, and then 6, then 10, 15, 21, and this would continue, okay? What I would like you guys to do is come up with a recursive rule for what's happening here. So not an explicit rule, a recursive rule. Now remember, the recursive rule means you're going to tell me how to find any term by taking the term that was in front of it and doing something to it. I don't know, add stuff, subtract stuff, multiply stuff, divide stuff. What kind of stuff? I don't know. You guys are going to figure it out. So I want you guys to think with your group for like 30 seconds to a minute to see if you can come up with a formula or at least a pattern of what's happening in here and how you think you could put that in here. And then we'll take some responses that you guys have and come up with the actual rule. Okay? But I want you guys to think about it a little bit first. Okay? So take 30 seconds, a minute with your group and see what, not perfection yet, but ideas. So I was getting asked some questions in the back, like, how do we say that we're not adding the same amount every time, but that it's like going up? So I don't know. How do we say that? Did anybody come up with an idea of how to say that? So can you just write a single number here? So it is the previous term plus some amount, right? But this amount is changing. It's not constant like it was with the cups. How can we use what we have here and put in there an amount that can change? We have variables in our problem. So far we have A's, which stand for terms in the sequence, but we also have N's. Okay? Yes, Ivan. Okay, so looking at, so these went up by 2, but this went up by 3. So it's however you can get the difference of the previous two numbers plus 1. So that's a good idea. So he's saying, say like AN is going to be AN1, A sub n minus 1 plus, and then he would actually take the difference of the two terms before it and then add 1. That's a really good idea. Okay? It doesn't technically work for the definition of what a recursive rule is because it's only supposed to depend on the 1 before it, and this would depend on the 2 before it. But that's the right idea. So there's a different way that we can express that, and it will still follow this rule of only using the term before it in our expression. So let's go through and see. Sometimes it helps you to look at some concrete examples, right? So to get the second term, right, you're taking the first term and you're adding. So I'm just going to make a list of the information we're going to collect. We're stuck, right? We don't know how to write this correctly. So I'm going to start going through some things. Okay, to get the second term, I take the first term and I add how much? 2. Right? To get the second term, I take the first term and I added 2. Right? All right, to get the third term, I take the second term and I add 3. Koji, are you seeing our pattern? Yeah, okay, give us 1 second. Maybe some other people will see you if we go like 2 steps further. Okay, to get the fourth term, I take the third term and add how much to it? To get the fifth term, I take the fourth term and I add. Okay, so how can I take this information and make it understandable over here and more generic? Koji, you want to tell them now? Right. So you're just adding 1 higher than whatever the subscript is right here. Do you guys notice that? So when I'm using the first term, I'm adding 2. When I'm using the second term, I'm adding 3. Or if you're finding the second term, you're adding 2. If you're finding the third term, you're adding 3. Okay, so whether we do what Koji said and said, well, it's 1 higher than this. What is 1 higher than n minus 1? Think it through a little bit. N minus 1 plus 1 is n. Does it make sense that saying add n here would be okay? When we were finding the fourth term, do we want to add 4 to the previous term? Yeah, right? To find the fourth term, we were adding 4. So see how when it's not consistent, So I was talking with Dominic, and he was like, I just want to make like a second equation because I could totally do that. So that's exactly what you're doing, but what you're trying to do is instead of making a whole new second equation, base that equation on n because it's something that people already have access to, okay? So recursive rule always has this on the left side. It always uses the term before it on the right side, and then you're either adding a constant amount or doing something with n to make this work, okay? So then people can still find the term that they need, all right? Is this okay with the difference between explicit and recursive? Do you understand that recursive is always using the term before and doing stuff to it? Explicit was where you just plugged in the n to figure it out, okay? All right, so we're actually going to skip some of this next stuff because we're going to focus on, okay. Turn it over on the back. And you guys don't have to do the questions yet. We're just going to focus on arithmetic sequences. Okay, so sequences are cool. Looking for patterns is really cool. Some of the patterns are really easily explained in math, and some of them aren't. And so certain patterns we've kind of grouped together, like, oh my gosh, this is amazing. Look, every time it happens like this, it's falling into this certain category. So one of those categories is arithmetic sequences. This isn't on your note guide because it's just kind of an introduction. You don't have to write anything right now. But I want to use our information from our cups to help us see when people might actually get an arithmetic sequence. Like, did they just make this up to make another branch of math? Like, no. Okay, and how it's actually related to a bunch of stuff you guys already know. Okay, so I'm going to graph our cup data. I'm going to call this x-axis number of cups. I'm going to call the y-axis the height of the stack in centimeters. I'm going to number it by 2s. So when I gave you guys the height of 1 cup, what did I say its height was? 14 centimeters. So 1 cup, 2, 4, 6, 8, 14. Okay. Then if we're using, I don't know, if we're using a 2 centimeter rim, if we're going to use that measurement, at 2 cups, what would be the height of our stack? 16. And then at 3 cups, 18. At 4 cups, 20. Okay, and so we can see graphically what this pattern is going to look like. Now, this is actually a really nice graph, right? You guys could have actually solved the problem you worked on this way, right? You could have figured out when the graph reached a certain height and saw it this way. Not for everything, but for this one, it works exceptional. What kind of shape are we making with our data that we have about our cups up there? Yeah, it definitely looks linear, right? If you were going to write an equation for this line, what would the equation be? This was at 14. So what would an equation be for this line? Okay, and there's one small adjustment we have to make. Your idea is right. My scaling is just different. Dominic? 2x. Is everybody okay with why the slope is 2? It looks like up 1 over 1, but what did I scale the y-axis by? 2. So it's really up 2 over 1, which is why the slope is 2. Right? Okay, so let's think about what this means, besides the phantom moving pen up there. Okay, so y-intercept of 12. What does that mean in the context of the cups, or what is it supposed to mean in the context of the cups? It means that if I kept going, this is right here, right? What does that little data point mean? Okay, so graphically, it's where the line hits the y-axis, or it's the y-intercept. What does it mean in the context of our cups? It's the starting point. And so it's saying at 0 cups, we have a height of 12 centimeters. Now, is that accurate? No. So what we're going to find later when we collect data is this data was clearly linear. There's a really nice line that fits this data, and we're smart enough with our Algebra 1 skills to find the equation of this line. But this equation has some limitations because we're talking about like real life, right? And real life doesn't extend forever in both directions and all this kind of stuff. Think about it. If there was no limitations to this, then I could say when we had -1 cups in our stack, which doesn't even make sense, that the height would be 10 centimeters high. Okay? So there's some clear limitations. The end of this unit is going to be all about data, lines that fit that data, and what things mean in the context of the real life data. Okay, so that's why we're kind of starting here and incorporating this with it. What does the 2 mean up here? Yes? Okay, so graphically, and for us as algebra students, it is the slope of the line. What does it mean in the context of the scenario we were studying, cups and height? Good. The height of the stack increased by 2 centimeters every time I added 1 cup. Okay? So that's kind of what's going on there, and it looks very linear. Now think about if I put this information in a chart, like an XY table, instead of a graph. Okay? So at 1 cup, 14, 2 cups, 3 cups, 4 cups. Okay? Now you guys could find this same equation using this information here if you counted these as points, found the slope, found an equation, all that kind of stuff. Okay? People basically take this information to make sequences. This is a sequence. What they basically do is cut out this column because all it says is 1, 2, 3, 4, 5, 6, 7, 8, 9. Why do we need to keep track of that when it's just starting at 1 and going in order? Instead, they say, let's just look at the outcome of the data. Okay? Let's just look at 14, 16, 18, 20. And if we call it a sequence, we automatically say this is the first one, this is the second one, this is the third one. If we were talking about cups, height of the first cup, second cup, third cup, fourth cup. If we were talking very technically in terms of a generic sequence, first term, second term, third term, fourth term, etc. Does that make sense where it's coming from? So it's coming from relationships you've already seen. They're just trying to use it in places where instead of having this 1, 2, 3, 4, 5, we can just look at the list of numbers and explore the patterns. Okay? What are the patterns that you see in the list of numbers here? Yes? Okay, good. So it goes up by 2. So this is a sequence, but this is actually not just any sequence. This is considered an arithmetic sequence. Okay? The reason it's considered an arithmetic sequence is because the terms have this constant change between them. Instead of like the block problem that we just saw, how it like changed every time and that was harder to express, these ones are a lot easier to express because the change is always constant. Okay? So that's what determines when something is an arithmetic sequence. So you see the words there, arithmetic sequence and common difference. So arithmetic sequence is what we just talked about. It's a sequence where the difference between consecutive terms, so things right next to each other, is constant. So if it's changing 2 here, it's changing to the next one, the next one, the next one. Okay? The common difference is the actual value of that change. If it's going up by 2, we call it plus 2. If it's going down by 2, we call it minus 2. Okay? So it's the change from first term to second term to third term. And next to common difference, you can write a lowercase d. Okay? Because we use the letter D notation-wise to represent that when we don't have it yet. Okay, so with our rule, since every arithmetic sequence follows this special pattern, and the pattern is kind of like a line if the slope is staying the same every time, right? If it's going the same amount of change every time, then it's got to have equations like this. So the question is, how do we get those equations? We could take every time, make a table like this, build our graph, and try to write the equation, but that's kind of a lot of work, right? So, of course, they came up with a shortcut rule. When you see arithmetic sequence, it's going to look like a line. How do we get the equation that's similar to a linear equation? And they have a way for us to do it. So let's look at where this comes from. So recursive-wise, you would say, well, don't know. Okay. Recursive-wise, we would say we find any term, and we already said this about the cups, so it's not that mysterious. We take the term before it and we add 2. For any arithmetic sequence or series, your recursive formula is going to say this plus or minus whatever your difference is between every term. Okay? The explicit formula, though, is what we really want. We want that rule that someone can go find the 100th term really quickly. So let's think about how this looks. Okay, so let's say you guys wanted to find the third term. Okay? To find the third term, you would take the second term and you would add 2, right? I'm going to rewind one and say to find the second term, I would take the first term and I would add 2, right? And then this would continue to find the fourth term. We already went through this whole idea, right? I'd take the third term and I would add 2. So let's try to make this more generic. Like, I don't want to use second term and the third term and the fourth term. I want to narrow it down to as little terms as possible as I need. Basically, what I really need to know is what does it start with? And then if I know this, I can get anywhere I need to get in the sequence, right? Okay, as long as I know what it's changing by each time and where it started. So this is okay. And what did we say we're going to call 2 in this case? In this instance, it's 2. But what did we say the vocabulary word is for what 2 is in this sequence? Good, the common difference. And what variable are we going to use for that? D. So I'm going to go ahead and I'm going to change this to D. Okay? So to get the second term, I would take the first term and I would add 1 difference. Okay? Now, to get the third term, let's say you started at the first term instead of the second term. If you start here, how many times do you have to add the difference to get to the third term? Twice. 1, 2, right? So here you have to add 2 times the difference. To get to the fourth term from the first term, how many differences do you have to add? 3 of them. So there's a little pattern forming here, right? To get any term, I can start at the first term and add the difference. How many times do I have to add the difference? So if I'm finding the 10th term, how many times do I add the difference to the first term? 9 times. If I'm finding the 20th term, how many times am I going to add the difference to the first term? 19. How are these numbers related? N minus 1. Good. 1 less every time. So if I want to find the nth term, I add the difference n minus 1 times. This is what we use to write rules for our formulas. It's just like using y equals mx plus b, but using the notation of the sequence since they're going to give us the information like this. Okay? So if we know the first term and we know the difference, we can write an equation like this, except for it's going to have an's and n's in it instead of x's and y's. Okay? So go ahead and write down this rule, okay, somewhere on your paper. It's only for arithmetic sequences, because remember, that rule only works when you can use that difference over and over again, so the terms have to have that common difference between them. Put it in a box or something. It's pretty important. Okay. I already did this. All right, so take a minute in your group and see if you could come up with a rule, or as far as you can get in coming up with a rule, if you know these 2 things. You know that the 7th term is 15, and you know that the common difference is -7. See if you can reason through, do some algebra, do some arithmetic to come up with a rule, and the rule needs to be explicit, like a sub n equals and something with n on the other side. No, it's not for that data. It's for any data that fits that mold, so basically any arithmetic sequence. So as long as you know it has a common difference, that rule will help you write the rule. Okay? All right, so go ahead. Okay, share with me some stuff that you guys know. So here's what I felt like I knew in a more, visual format. For those of you that were struggling with a starting point, you know this. At the 7th term, you have 15, and you know to get from term to term, you're subtracting 7 each time you move forward a term. I don't know. So there's what I know in a more like list format instead of just what's given. So somebody give me ideas of how you figured out different information. Yes? Add 7? Okay. And do I get the 8th term or the 6th term that way? Oh, if I add 7, how many times? 6 times. Okay. So he's saying add 7. Why is he saying add 7 instead of subtract 7? Good. As I'm moving each term forward, it's going down 7. So if I'm trying to work back to the beginning, I need to be going up 7 to see what that looks like, right? So going backwards 1 would be 22. If you kept doing this, you could get to the beginning. Or we said shortcut, If you know you're going to be adding 7s 6 times, because if I gave you the 100th term instead of the 7th term, you probably wouldn't want to just keep adding 7, okay? So I'm going to be adding 7 6 times. 7 times 6 is 42. So it's like I'm going to be adding 42, which means the first term will be 57. Okay? All right, so now we can actually use our rule because we know enough of the information. So to write our explicit rule, we said you always want to take the first term. You want to add to the first term the common difference. And you want to add it a certain number of times depending on which term you're getting to. If I'm going to the nth term, I'm adding it 1 less than that, n minus 1 times. Okay? And I'm not going to plug numbers in here or here. That's when I want to know a specific term. Right now, I'm trying to write a rule, something useful for someone else to find a specific term. Okay? So then I would just work like I would a linear equation to combine like terms. I would distribute. And I would get that a sub n equals 64 minus 7n, or you can write it as negative 7n plus 64, if you're kind of used to that y equals mx plus b format. Okay. And so this would be our rule for the nth term. And now anyone could come and find any term that they wanted using our rule. Any questions about that process? So the pattern makes it a little bit easier, even if you don't know a specific equation or something, to get what you need. Like figuring out the first term here. Yeah, question? Yeah. Oh, yeah. Mm-hmm. So now slightly different scenario. 2 terms of an arithmetic sequence. So you know at some point there's the 7th term, and it's 20. And then at some other point there's the 23rd term, and it happens to be 52. And first we're supposed to write a rule, and then we're supposed to figure out some other information. Okay? All right, so what do I need to write a rule? What did we need last time? What were kind of the important pieces to be able to write that rule? The difference. What else? The first term. Okay? Because we need the starting point and how many we're skipping every time, right? Any ideas on how to find either one of those things? Yes? No? Hand up? No? No? Koji? Mm-hmm. Okay, so what he's saying is I know it goes from 20 to 52. So think about what happens there. 52 minus 20 is a difference of 32. So the terms in our sequence have increased by 32 units, going from the 7th term to the 23rd term. Does that mean that the common difference is 32? No. Okay. Then I need to figure out what am I changing each time if it's changing for a total of 32. So what do I need to do to figure that out? Divide it up, right, into how many different changes was I making. So how many times are you using the difference if you're going from the 7th term to the 23rd term? 16 times. And if those of you that are wondering how did we get that, we did 23 minus 7. So there's 16 terms to get from the 7th term to the 23rd term. So 32 divided up into those 16 different changes that were made gives us a common difference of 2. All right, you guys said the important things were the common difference in the first term. How do I get that first term? Yes? Okay, good. Basically subtract 2 6 times from the 7th term, right? So how much am I subtracting in total? 12. Okay, so 20 minus 12 gives me 8. So my first term is 8. And then I'll use those things in that formula that makes it a little quicker than going through everything lots of times to write my rule. So the first term is 8. I'm adding a common difference of 2. I'm adding it n minus 1 times for my formula. My formula is about an. Again, we'll distribute. And so we're going to get an equals 2n plus 6, or 6 plus 2n. However you want to write it is fine. Okay. So any questions about this, you should be thinking, do I understand how they got the common difference? Do I understand how using that I can find the first term? You're going to want to know the formula for the rule, right? It makes it quicker to figure out the equation. And so do you understand how to put that together? So do you understand how to find a difference? Do you understand how to find a first term? Do you understand then how to use this formula to put it together in a rule? Those are kind of what you're thinking about right now. Okay? Yes? Good. Okay, so how do we get the first term again? So once we know the difference, we're going to look at the term that we have that's closest to the first term. You don't have to. You could use the other one if you want. Think about it. If you want to get all the way back to the first term, you know the differences too. So that means the first term went up to 6 times to get to the 7th term. So it basically went up 12 because the difference was 2. So instead of going up 12, though, I'm trying to work backwards. So I subtracted 12 to get 8. Is that okay? So I'm using the common difference, but I'm thinking about going backwards instead of forwards. So instead of plus 2, I'm thinking minus 2. And then I'm thinking, how many times would I have to do that to get from the 7th term back to the first term? So I'd go 6, 5, 4, 3, 2, 1. So I would basically have to do that minus 2 6 times. So minus 2 times 6 is 12. So I'm doing 20 minus 12, which gives me 8, which is the number that would be sitting in the first one. Does that make sense? Okay, good. Other questions? Okay, then what is part B asking? Find the value of n for which a sub n equals 44. First of all, someone break it down to me in, like, what are we finding and what are they giving us? So they tell me a sub n equals 44. I'm supposed to find n. What does this mean in the vocabulary of sequences? What am I looking for? Yes? Okay, so we are going to use the explicit rule. Okay, what are they giving us? Are they giving us the term number or the actual term? What is 44? Is it a term in our sequence, or does it mean the 44th term? It's a term in the sequence, right? There's a number in the list somewhere that is 44, okay? How do I know that? Because an A is equal to 44. Remember, A means there's a number in the list. So some number in the list is 44. Do we know which number in the list? No. That's what we're focused on finding when we're finding n. We're trying to figure out which one it is. So formula-wise, using the explicit formula, it literally means that where an is, you're going to plug in 44, because it says a sub n equals 44, okay, or you know the term is 44. You know this is the rule to get that term, so you're going to use this to solve for n, meaning figure out what somebody must have plugged in for n in order to get 44. Before I finish solving it, approximately around which terms should it be? Look at what you know so far about your sequence, because we want to make sure our results are valid. So as I'm doing this, 44, where would it be in the list? Would it be before the 7th term, between the 7th and 23rd term, after the 23rd term? Between these. If I get something different than that, I have a problem. Don't leave that and box it because you think it was all perfect. Make sure your mind is thinking about if it actually fits with the information you were given, okay? So if we solve this, if we subtract 6 from both sides, we end up getting 19, okay? So n is 19. That means 44 is the 19th term in the sequence. That makes sense because it should be between the 7th and the 23rd term. Did that answer your question?